Good evening, everyone. I request Gurvinder sir to conduct the session.
Thank you, sir. I hope I'm audible.
Yes, sir, you're audible, sir.
Okay, thank you. So, hi, hello, everyone. We'll be starting today's session. So, yesterday we were discussing about limit of sin x by x. Okay. So, I just had a very brief trick to discuss with you regarding yesterday's questions that we have done. So, see, it is quite intuitive. See, if I have limit x tends to 0, sin x by x. Okay. So obviously, you know, what is the value of this limit? It is 1, right? Okay. So similarly, if I have something, any function inside my sign, okay. So I'm taking any function f of x inside my sign. What will this thing be equal to? Can anyone tell me? What will this thing be equal to?
1.
Yes, because
So
instead of x, now I have taken f of x, right?
f of x.
And I have changed my limit
Yes.
to f of x tends to 0. So this thing is 1, right, everyone? Agrees to this?
Yes.
Okay. In other words, I can take this f of x to this side. So I can also say that limit f of x tends to 0, sine of f of x is equal to limit f of x tends to 0, f of x. Right? Can I say this? I'm just
Yes.
taking this f of x to the right side. Okay. This is not wrong. So what is happening in this trick? What is happening in this trick? See, sine of f of x is equal to f of x when my f of x is tending to 0. So basically, I have a function inside sine of f of x. Okay, something like this. Any function inside sine. I don't care what the function is. As long as the function is tending to 0, I can ignore my sine function. Everyone understood the trick? I can just easily remove my sine function and just take my f of x really easily, right?
Yes, sir.
Okay. So, so I'll just give you one small question. So I have limit x tends to 0, sine of ax by sine of bx. So yesterday, the way we solved it, it was really long, right? It went really long. But I just have a very small trick to share with you that you can ignore the sine function as long as the quantity inside your sine, okay, whatever the quantity inside your sine, it is tending to 0. So if my x is tending to 0, my ax will go to 0. Is that right, everyone?
Yes,
If
sir.
my x is tending to 0, so a into x will also go to 0. So that means I can just remove my sign from here. So ax divided by, same way I can my sign from denominators bx, and I got my final answer a by b. Right? Got it, everyone? I just ignored that thing. Same thing. Limit x tends to 1, sine of ln x divided by ln x. So if my x is tending to 1, where is my ln x going to? If my x is close to 1, where is
Sir,
my ln x going to?
Helen. Helen. Helen, sir.
ln. Arey yaar. If my x is tending to 1, where is my ln x tending to? That is what I'm asking.
1.
Ln means log x. Ln, okay, so I guess, so ln means log. No issues if you didn't know, but I guess you should have known this. If my x is tending to 1, where is my log x tending to?
0, sir. 0, sir.
0. Yes, obviously, because log of 1 is 0, right? So this is tending to 0. I can
Yes,
just remove my
sir.
sign, so it turns out to be log x by log x. So 1. Fine, everyone? Got this?
Yes, sir.
So now you can just remove your sign wherever, but just keep in mind that you can only do this when the inside function is tending to 0. And the same thing you can do with tan also. Okay. The same thing works with tan also. Right? The same thing. You can do the same thing. You can ignore your tan function because tan x by x is how much? What is tan x by x when x is tending to 0?
1.
How much is it? So you can
1.
like intuitively think for tan also. Right? Okay. So regarding this property, let us just do a very small question. So I have limit x tends to 0 plus sine of kx. Okay, this is kx plus cos x plus x minus 1 whole divided by x is equal to 3. Okay, so it is asking me the value of k. Can we do this? Can you think how we can do this? So the first part, just look at the first part. We have sine of kx. Sine of kx. What will happen to this thing? How can I write this thing? Do you all agree that kx is going to 0? If x is tending to 0 plus, where is my kx going to?
0.
0.
Yes, correct. If my x is going to 0 plus, my kx will also go to 0 plus. So not an issue. I can just remove my first sign, right? So it just remains as sine of kx. Now again, this thing is 0. So I can just write it as kx. Got the trick?
Yes,
Does
sir.
everyone agree with this? Can I remove my sign 2 times?
Yes, sir.
Is it allowed? Yes, obviously it is allowed. As long as my quantity inside the brackets of sign is tending to 0, I can do this. It is absolutely allowed. So it turns out to be kx. I just got kx plus cos x plus x minus 1 whole divided by x. And this thing is equal to 3. Okay. Fine, everyone.
Yes,
Can we now
sir.
find the value of k? Can we find the value of k now?
Sir.
How do we find the value of k?
Sir, we should
Tell
separate by
me. How do we
denominator.
find the?
In place of x.
Yes, absolutely correct. Yes,
Zero.
yes, correct, absolutely correct. We should substitute by denominator, correct. So k plus 1, okay, k plus 1 into x plus cos x minus 1. So this divided by x, this divided by x. So can I cancel my x and x from in the left term?
Yes,
X
sir.
and x in the left term, can I cancel it out? Yes, I can do it.
Yes.
And what about the right side? Cos x minus 1 divided by x. What can you do? We have done such a question yesterday, if you remember. Do you remember the formula of 1 minus cos of 2x? What is it? 1 minus cos 2x. Right. It is sine square x. So what will be 1 minus cos of x? 2 sine square x by 2.
Sine square x.
Right?
Yes, sir.
Yes, sir.
Right, everyone? 2 sine square x by 2. Okay. So this thing will become minus 2 sine square x by 2 whole divided by x. Now, how would you solve this thing? How would you solve this thing? Can you tell me? Anyone? We have 2 sine square x by 2. So again, just remember that trick we are discussing about. What is the trick?
Removing sign.
Removing sign.
So remove sign. Remove sign. So remove sign. Na? So minus 2 into. So what will be this thing? What will come out over here?
By 4. Sir, x square by 4.
How much?
X square
Correct,
by
correct. It will be x by 2 whole square. Yes, correct, correct. Because there is a square with sign.
Yes,
So
sir.
both of my signs will needed to be removed. Right? So minus 2 x square by 4 whole by x. How much will this value be?
Minus x
How much will this
square by
value?
2
square by 2 divided by x.
by x.
So okay, correct. So minus 2 x square by 4x. So it is minus x by 2. How much is this now? Minus x by 2, limit x is tending to 0.
0,
X
sir.
is tending to
0,
0.
sir.
0.
0, sir.
0, sir.
It should have like, okay, wait. So I have got k plus 1 plus 0 is equal to 3. So k is how much? 2. Fine. K is 2.
Yes, sir.
Got it, everyone?
Sir, how you got
Okay,
k plus
great.
1?
Really.
I mean in above
See,
equation.
because I have k plus 1, you see, I have kx and x. So kx and x. So I got k plus 1x. Fine. Kx and 1x. So x into k plus 1. I took it common. Okay, great. So just one conceptual question to discuss before moving ahead. So I I wanted to ask you, limit x tends to 0 plus, okay, plus gif of sin x by x, and limit x tends to 0 plus gif of tan x by x. Can you think of this? GIF. First of all, everyone knows GIF now, right?
Yes,
At
sir.
least today, no one should be there who says that I don't know GIF. Okay, great, great. GIF, okay, great, great work. So we are trying to take the greatest integer function of sin x by x and tan x by x, and trying to see how it is like what will happen. Is this value actually greater than 1 or lesser than 1? Same thing we are trying to see over here. Is the actual limiting value greater than or lesser than 1? So,
Great.
like, what would be the easiest thing for this? What would be the easiest? Obviously, like, I can just write sin x as my infinite expansion. So I have x minus x cubed by 3 factorial plus x raised to 5 by 5 factorial minus x raised to 7 by 7 factorial and so on. Same thing, I can write my tan x as x plus x cubed by 3 factorial plus 2 by 15 x raised to 5 and so on. Oh, sorry, it is not 3 factorial, it is 3 x cubed by 3. Fine. Everyone agrees to this thing?
Yes, sir.
Like, there was nothing to agree with actually. This is just the expansion. So sin x by x, you divide this thing by x. What do you get? You get 1 minus x square by 2 factorial, by 3 factorial, plus x raised to 4 by 5 factorial, minus x raised to 6 by 7 factorial, and so on up to infinite terms. Fine? Fine.
Yes.
Everyone? Achha, so just tell me one small thing. If x is tending to 0, I have a list of terms. Okay. I have x square, I have x raised to 4, I have x raised to 6, x raised to 8. Which of these will be the largest? Is x square or x raised to 8? Which of these is larger?
X raised to 8, sir.
0, sir.
X raised to 8 is the largest.
Raised
X
to
is close to 0.
Sir,
How much?
all are equal now.
All are equal. No, like obviously the limiting value of everything is 0. I know that. The limiting value of each of these is 0. You put x as 0, this is also 0, this is also 0. But I'm just asking you to compare which of these will be greater or which of these will be which of these will have a larger value,
X square,
smaller
sir.
value.
X square,
X
sir.
square will have a smaller value. That
No,
is
sir,
what you mean?
larger.
Larger.
Okay, correct. Correct, correct. So
Value, sir.
x square will have the largest value, x
Yes,
raised to
sir.
4, and right, everyone. Everyone agree to this, right?
Yes, sir.
Right, everyone? Yes, and this is correct also. Because you take any number between 0 and 1. You take any number between 0 and 1 and you square it. So actually the number becomes smaller. Like you take half. or any number smaller. So like it goes on becoming smaller and smaller and smaller. You choose any number. Same way you take 1 by 10, 1 by 100. So the number actually keeps on decreasing. Correct. So can you just tell me, I have this infinite expansion, 1 minus x square by 3 factorial plus x raised to 4 by 5 factorial minus x raised to 6 by 7 factorial. Can you help me to tell me which of these terms, I have total infinite terms in this, which of these terms will have the highest contribution to the series?
Square by
Will
3
x square have the
factorial.
highest contribution? X raised to
Yes,
4,
sir.
x raised to 6.
X square, sir.
What? Which term?
For x power
Yes,
4.
obviously, x square. Because x square has the largest value,
Yes,
right? X square has the largest value, so it will have the largest contribution. Absolutely correct. Everyone?
Yes, sir.
Okay, so
Yes,
I
sir.
hope my voice is my voice is clear.
So minus sign is there, no, sir. To x square.
So
Row
how should that have any problem? Like, why should the minus sign have any issue with that? I'm just asking you which of these terms will have the highest contribution, the highest value in the series. Obviously, it will be x square. X square will
yes,
have the
sir.
largest contribution to the series. So x square has the largest contribution. Obviously, correct. And while discussing about limits, we only talk about the largest contribution. All the other higher order terms are ignored. Okay. Because if x square, see, just remember, x is already tending to 0. Okay. X square will even be smaller than that. And x raised to 4, x raised to 6, all of these will definitely be smaller than that. So I can say that sine x by x, it is 1 minus x square by 3 factorial. Okay. And then the higher order terms. So is this thing 1 minus x square by 3 factorial? If x square has the largest contribution, is this thing greater than or lesser than 1? Is this thing greater than or lesser than 1 minus x square by 3 factorial?
Lesser than 1, sir.
Second, sir.
Tell.
Sir, then 1.
Hmm.
Sir,
Lesser
then.
Greater
than 1, sir.
what? Lesser than 1. Correct. Sin x by x will actually be lesser than 1. If you can just think of it. Right? Everyone agrees to this?
Yes, sir.
It will be a value it will be lesser than 1 for sure. So can you just tell me now, your GIF of sin x by x, when x is tending to 0, where will it go? Where will it go?
1, sir.
1, sir.
1.
1.
One, sir.
Shabash, shabash. It is lesser than 1.
0, sir.
Eh, yaar.
3.
Are you sure you know greatest? Okay, I will just tell you again. See, this is my number 1. This is my number 0. I am talking about a number that's lesser than 1. Okay. It is not equal to 1. So where will my greatest integer function take it? Omkar, Gayatri, Preeti. Greatest
0.
integer function.
0.0001.
Yes, correct. So it will be greatest integer of 0.99999 so on.
Yes,
So
sir.
what is this thing? Like 0.99. What will, like my final answer, what will it be?
1. 0, sir.
1.
Sir.
अबे यार भाई मेरे को हार्ट अटैक दे दो यार तुम लोग. Sure. Preeti, right?
Yes, sir.
Ashrita,
Sir.
Shravani. Hmm.
0, sir.
Tell, what is the greatest integer function of 0.9999?
0, sir.
Obviously, yes, 0. Because this thing is lesser than 1, right? Just like for the ones who don't know greatest integer function, you can see that relations and functions chapter. In that, I have taught it clearly. See, just remember, if I'm talking about the exact value 1, this will turn out to be 1. If it grows just a little bit lesser than 1, it will bring it to 0. That is how it works. Fine. So you should know greatest integer function. Okay. Let us just look at this. What will be my value of tan x by x? So it is 1 plus x square by 3 plus 2 by 15 x raised to 4 and so on. Fine. So which of these terms will have the highest contribution?
Sir, x square by 3.
Everyone? Obviously x square. X square has the highest contribution. Okay, correct. Highest contribution. So like I have tan x by x 1 plus x square by 3 plus higher order terms. So is this thing tan x by x greater than or lesser than 1? Is it greater than or lesser than 1?
Greater than 1.
Greater than, sir.
Okay, now take the greatest integer function of this thing. Where will it go?
Greater than 1, sir.
1.
How much?
It is
1.
greater than 1.
1, correct. It is greater than 1. That is why it will bring it back to 1.
Yes, sir.
It will bring it back to 1. Okay, great. So, okay, I will just give you 1 or 2 similar questions in homework. So I have limit extends to 0 plus sin x by x ka greatest integer. Sorry, it is the least integer. Okay, least integer function. Same way, 0 plus least integer of tan x by x. Now I have one special question. Okay, so these two are really simple, but this one is a bit difficult. Limit extends to 0 plus greatest integer function of sin x into tan x by x square. Okay. So what is special in this question is, I'll just tell you one thing. See, you all know that sin x by x is lesser than 1, okay? And tan x by x is greater than 1. So basically what is happening in this question is we are multiplying these two, okay? We are multiplying these two, and through the multiplication you will need to tell, is the multiplication of these two things greater than or lesser than 1? So hope you will be able to do it. The first two are really simple. You can just do it now itself. Fine? Everyone?
Sir.
Okay. ये तो यार मतलब if I was in your place, the first two I would have done like just
Sir, it is 1, sir.
now only.
First one is 1,
1.
sir. Second one is 2,
First
sir.
one is 1.
Yes,
Just a
sir.
second.
Second one, 2.
First one is 1, second one is 2.
2.
Correct, correct. Absolutely correct.
2.
Yes, correct. Okay, great, correct. So, okay, great work. So today I'll be just introducing you to the indeterminate forms of limit. Okay, so what is meant by the indeterminate forms of limit where direct substitution fails? Okay. What does this mean? Direct substitution fails. So till now, yesterday we were discussing about questions wherein you were directly substituting the values of x, okay, in the limits. Like for example, I give you any polynomial function, like anything like x square plus 2x plus 3, x cube plus 3x square plus 8x, something, anything like this. And I give you a value. So you can just directly plug in the values of x and get your limits, right, everyone? You can just plug in your values of x and get in the the limits. But now we will be discussing about cases where things won't be that where you can't be inputting the values of x and getting your answer. So one of the cases we have discussed just now, if you remember, yesterday also we have discussed such a case. What was that case? Now what are all these cases? What is sin x by x? Yes, correct. 0 by 0. Absolutely correct. So there are total 7. Okay, there are total 7 indeterminate forms wherein you can't substitute the values of x. Okay, so till now we were discussing about 0 by 0. 0 by 0 is the most intuitive of them all because everyone, even a 7th or 8th class kid knows that 0 by 0 is not defined. Okay. Similarly, there are 6 more cases. There are 6 more cases where you will not be able to put your values of x and get your value of the limits. Okay. What are those 6 more cases? If anyone has studied in college, maybe. Second case is infinite divided by infinite. Okay. Third case is 0 multiplied by infinite. Then we have
1 by
0 raised to
infinite.
0. 1, how much? 1 divided by
Infinite.
1 divided by infinite. Is this a indeterminate form? Can you think? 1. My numerator is 1 and my denominator is turning out to be really not a large number, a very large number. So is this a indeterminate form? 1 divided by a very large number. I can just easily say that this value will be close to 0. Why
Yes.
should this thing be an indeterminate form? 1 divided by infinite is actually 0 only. So why should I be doing that? So see, 0 by 0, correct, it is not defined. Same thing, infinite divided by infinite is not 1. 0 multiplied by infinite, it's just a part of this. Then we have 0 raised to 0. Okay, then we have infinity raised to 0. Then we have infinite minus infinite.
1 raised.
And then we at the last we have 1 raised to infinity. Correct. So you have studied this in college, I guess.
Yes, sir.
Right? Okay, great. So if anyone feels that there is any indeterminate form left, or any one of you feels that one of these is not an indeterminate form, you know the value of this thing. So yes,
Something
you can ask.
is not
What?
defined in us, sir.
What?
Uh,
Mm-hmm.
thing by 0 is not defined in us, sir.
Can you repeat what thing by 0?
Sir, any value by 0 is not defined in us, sir.
Yes, it is not defined. So, okay. So, like, what do you want to ask? It is, yes, it is not defined. So, ask your doubt, complete your doubt at least. What were
So,
you trying to say?
वो
हाँ.
form यहाँ पर नहीं
Okay, so
लिखा.
you mean, acha, you mean any constant divided by 0. That is what you mean?
Yes, sir.
Okay, no, this will not be an indeterminate form. I'll tell you why. I'll tell you why. Okay. So, okay, great example to start with. Okay, so I
Sir,
have
1
limit
power
x tends to 1 power.
infinity, sir. 1 power something
No,
will be 1 only, no,
1 power
sir.
infinity is not 1. No. I'll tell you why. I'll give you the reason just after I have completed this thing. So I have limit
Okay.
x tends to 0 plus. Okay. And then let me take a value 5 divided by x. Okay. So this is what Gayatri had told. Gayatri, right? Constant divided by 0, right? Okay. So let us just give a look at this. What will happen? So I have limit x tends to 0 plus 5 divided by x. So see, 5 is a finite value and x is a really small value that is positive. Okay. X is a really small value that is positive. So can you think what will happen if I divide 5 by a positive value that's really small? Where will this value grow? This value will become really large value. Everyone agrees to this? Everyone is
Yes,
right.
sir.
It will be a very large value. And is this value positive or negative large? Is this value positively large or negatively large? Like in the negative side or in the positive side?
Positive side.
Is this value positive? Yeah, obviously it is positive. So what do you call a number that is very large and on the positive side? What do we call it?
Plus infinity.
Or rather, you can just call it infinity if you wish to. Or okay, plus sign to denote it. Correct. So how is this thing an indeterminate form? Why was it indeterminate? It was not indeterminate. I hope you got your answer.
Yes, sir.
The one who had asked. Okay. So anything divided by 0 is not an indeterminate form. So I would just want you all to guess the second question for me. Limit x tends to 0 minus 3 by x. Can we do this? So it is 3 divided by a
Negative.
very small negative number.
Yes,
Where will this
sir.
thing grow to? Right? Where will this thing grow?
Negative.
Okay, correct. Negative
To
infinity, correct.
minus infinity.
Because my
Yes, sir.
denominator is negative. Correct? Okay.
Yes, sir.
Negative infinity, absolutely correct. And yeah, now the one, I'm not sure of your name. So you were asking 1 raised to infinity, right? 1
Yes.
raised to infinity. See, 1 raised to anything, you are correct. 1 raised to anything is 1. So yes, 1 you multiply any times you multiply 1 with 1, it will turn out to be 1 only. But the point is that when we talk about limit, okay, so I have a function f of x raised to another function g of x. Okay, what is happening is the limit of this thing, is going close to 1. So it may approach 1 from the right side or the left side. Okay, so the limit of f of x. So the function f of x can either have a value that is larger than 1 or it can have a value that's lesser than 1. So what will happen is when you multiply a number that's larger than 1 with itself infinite times, so it grows to infinite. And when you multiply a number that's lesser than 1 with itself infinite times, what will happen to this function? Can you guess? A number that's lesser than 1. Okay. A number that is lesser than 1, you keep on multiplying with itself infinite times. What will happen to the value of the function? Take any number.
Minus
Take, where will it go?
Minus infinity.
minus infinity.
Where will it go to? Why will it be negative? Like, why should it be a negative number? So you can just think of any number between 0 and 1. So just take 1 by 100. Okay. You keep on multiplying this number with itself infinite times. Where will this value go to?
Infinity, sir.
1 by infinity.
Positive.
Infinity.
One by
1 by, correct. 1 by infinity. What is 1 by infinity? What is 1 by
0.
infinity?
0.
Correct. 0. 0. Correct. It is 0. So see, there are two possible cases. Either if your f of x, your f of if it if f of x raised to g of x you have, and f of x is lesser than 1, so this thing will go to 0. And if you have your f of x greater than 1, it will go to infinity. So isn't this an indeterminate case? It is not equal to 1, right? See, if your value is 1 raised to exact 1 raised to infinity, see, I'm telling you that this value is exact equal to 1. So then obviously you can say that my answer is 1. But when you don't know if your value is greater than or lesser than 1, so you can't say this. Fine? Do you get it? Because
Yes.
you are not
Yes, sir.
sure if your f of x is lesser than 1 or greater than 1. So since you are not sure about that, you don't know if your value will turn out to be infinite or will it turn out to be 0. It can grow to any of these. So, okay, so these are my 7 cases, 7 forms, limit indeterminate forms. So we will be continuing our discussion with 0 by 0 for the time being, but just keep in mind that that all of these are the 7 indeterminate forms. Okay, so obviously, like yesterday we were doing with 0 by 0. So today some of the questions of 0 by 0 are left, that we'll be discussing them today. Okay. So I have limit t tends to 0, t plus a whole raised to n minus a raised to n whole divided by t. Which form is this? Sorry. Like, obviously it is 0 by 0. Everyone realizes, is this 0 by 0 form? Everyone?
Yes, sir. Yes, sir.
Is this
Sir.
0 by 0 form?
Yes,
It
sir.
is 0 by 0 form. Because you substitute t as 0, so a raised to n minus a raised to n. So it will be 0 in the numerator. Same thing in the denominator, it is already 0. So yes, correct. It is 0 by 0. How should we solve this one? How could we solve this one? T raised to n. How could we do this? So for this, just a very small trick. I have t plus a whole raised to n. I can take a common from this. So it will turn out to be a raised to n into 1 plus t by a whole to the power of n. Is this correct, everyone?
Yes, sir.
Right?
Yes, sir.
Okay. Great. So I hope all of you know what is the expansion of 1 plus x whole to the power of n. Just taught it in the previous class. I mean, sequence and series last class. So, okay. I am pretty sure all of you don't know. So it is 1 plus nx plus n minus 1 by 2 x square. Okay. n minus 1 n minus 2 by 3 factorial x cube and so on. So can you just see a relation between 1 plus x raised to n and 1 plus t by a raised to n? So in place of x, can I just directly substitute t by a? Can I
Yes.
substitute t by a?
Yes,
Yes,
sir.
I can do this. So it is a raised to n into 1 plus nx. So it will be n into t by a plus n minus 1 by 2 factorial t by a whole square and so on, higher order terms. Fine? Correct, everyone? Everyone?
Yes, sir.
Okay.
Sir.
So now this is my expansion of t plus a whole to the power of n. So I can just substitute it over here. I have this thing. So I'll just open the brackets up. So it is a raised to n plus n into t into a raised to n minus 1 plus, okay, so n minus 1 by 2 factorial t square a raised to n minus 2 and higher order terms. Okay. So I'll just substitute these values over here. So I have a raised to n plus n t a raised to n minus 1 plus n minus 1 by 2 factorial t square a raised to n minus 2 and higher order terms. And I have minus a raised to n whole divided by t. And my limit t is tending to 0. So a raised to n got cancelled. So this t by t, what will it be, everyone? What will this thing become? Can you help me solve? How can we solve this thing? What happened? Tell, how should we solve this thing? Just break your denominator into all of these, right?
Yes, sir.
So we have n a raised to n minus 1 plus n minus 1 by 2 factorial t a raised to n minus 2 and higher order terms. And now I need to substitute my value t to 0. What will it be? T tends to 0. What is t tends to 0? Substitute t tends to 0 over here and tell me the answer.
And
Tell.
N into a raised to n minus 1.
Right. This will be the only thing left.
Yes, sir.
Everything else will go to 0. Sorry?
Yes, sir.
Because all will have the remaining all terms have t in that. All the remaining terms have a t in that. So obviously, if t is tending to 0, all of the order to 0. So this is my answer left. N into a raised to n minus 1. So this value is n into a raised to n minus 1. Just changing this thing limit a bit. I hope you all remember the change of variables that we were discussing yesterday. How do we change the variables? So in this thing, I am asking you to take a variable x that is t minus a. Can we do this? Okay, let us take it as t plus a. Take x, a variable that is t plus a. So if your t is tending to 0, where is your x tending to?
A, sir.
Yes, sir.
Correct, correct. So this limit can be written as limit x tends to a. So now instead of t plus a, you will need to write x. So it is x raised to n minus a raised to n divided by what will be the denominator? What will be the denominator?
X, sir. X.
X. भाई
X.
साहब x क्यों होगा? Why will it be x? I have a t over here, right?
A, sir. A.
Oh,
A. अरे यार t. What is the relation between t and x? Use this thing now. How do I write t in terms of x? I have
X
a t over here, okay? X
X.
minus a.
X minus A.
And what is the value of the limit? N into a raised to n minus 1.
Yes, sir.
Is this 0 by 0 form?
Yes, sir.
Is this 0 by 0?
Yes, sir.
Okay, great. Everyone agrees. Yes, correct. It is 0 by 0. It is 0 by 0, so that is why we could have done it like we have done it easy. So great. We have got a really good thing to solve and a really good property through which we can do a few questions. Okay, great. So
So how you get the final value?
my final value is n into a raised to n minus 1, right? N into a raised to n minus 1. So it will remain same. It remains same. The right hand side won't change. My right hand side value won't change because it has got nothing to do with t. That is why.
Okay.
Okay, so let us just do a simple question. Limit extends to 2 x raised to 10 minus 1024 whole divided by x minus 2. What will it be equal to? X raised to 10 minus 1024. So you can see this thing as limit extends to 2 x raised to 10 minus 2 raised to 10 whole divided by x minus 2. Everyone
Yes, sir.
got it?
Yes, sir.
So tell me, what will it be equal to?
n into 2 raised to 9.
N into 2 raised to 9. What is the value of n?
10
What is the
into
value of
2
n
raised
over
to
here?
9, sir. 10 into 2 raised to
I
9.
said 10 into 2 raised to. Correct. 10 into 2 raised to 9. Absolutely correct. So yes, your value of n is 10 over here, right? So, and your value of a is 2. So really simple. This one was really simple. I hope all of you have got this. Any doubts? Anyone? Anyone? Okay. Can we think of this? X raised to 10 minus 1024 divided by x raised to 5 minus 32. How can we do this? How can we do this? Anyone? No one? Okay, so like we have x raised to 10 minus 2 raised to 10 divided by x raised to 5
Raised to 5
minus 2
minus
raised
2
to 5.
raised to 5.
2 raised
So
to
I can just divide x minus 2 in the numerator and in the denominator. Fine. And evaluate these limits separately. So my numerator value will be 10 into 2 raised to 9. And what will be my denominator value? Denominator value? Anyone?
5 into 2 raised to 4.
5 into 2 raised to 4, correct. So it is 2 into 2 raised to 5, or it is 2 raised to 6. Right? Everyone?
Yes, sir.
Correct, everyone?
Yes, sir.
Hmm. Okay, great. Let us just one similar easy question. Tell me. Limit x tends to 2, x raised to n minus 2 raised to n divided by x minus 2 is equal to 80. So what is the value of n? Anyone? First of all, what is the value in the limiting form? So x raised to n minus 2 raised to n by x minus 2, where limit x is tending to 2. What is this value? It is n into
2
2 raised to
raised
n minus 1.
2 raised to n minus 1.
And this value is equal to 80. So can we
80.
just think of a value? Can we just think of a natural number value of n where it satisfies this? Can anyone think? Any value? A natural number, we have to take natural numbers. So, okay. No one can think. Vignesh,
1 minute. Sir.
Ashrita, Gayatri. What could be the value of n? Just think in this case. Like you can just directly check by plugging in values. You can
5, sir.
substitute
5.
n as
N
1,
value
n
5,
as
sir.
2. Ah, yes, n is 5. Correct. I don't know why. Like maybe you are not in the mood to answer. Correct. N is 5. Really simple. Can we do this? X plus 2 minus a plus 2. Anyone?
Yes.
How we can do this? Tell. I don't know why. Maybe you are finding the questions too easy if you have studied in your college.
X plus 2 minus a
Right,
minus a
everyone?
plus 2. Yes, sir.
Yes, sir.
Right? Everyone agrees to this. So what would be our next step? What is the next? How do we think in the next step? Tell. We have got such a thing. Is this 0 by 0? Is this 0 by 0?
Yes.
Yes, sir.
Yes, sir.
It is 0 by 0. So how we could approach this thing? Like it is really simple. I don't know why. You are not answering. So you could just easily take that you have a variable y whose value is x plus 2. So if your x is tending to a, your y is tending to a plus 2. Okay. So you can just convert it. Limit y is tending to a plus 2. So y raised to 5 by 3 minus a plus 2 raised to 5 by 3 whole divided by y minus a plus 2. Now, do you see something? Do you see something over here? अरे यार, at least speak something.
Yes, sir.
Are you able to generate a relation between this thing and this thing? Just the value is that instead of a, now we are taking a plus 2.
A.
So how should that be an issue? A, if a is a constant, a plus 2 will also be a constant. So it has got nothing to change. So tell me, what will be this value equal to?
5 by 3.
First of all, what is my value of 5 by 3 into a plus
A plus 2
a
raised
plus
to
2 to the power of
2 by 3.
5
how much?
minus
2
1.
by 3, correct.
5 by 3
Minus
minus 1.
5 by
2 by
3 minus 1. 5 by 3 minus 1 is 2 by 3 only. So yes, it is correct. Correct. Okay, great. How do we do this? Is it 0 by 0 form? 0 by 0?
Sir,
Yes, sir.
Yes, sir.
Ah, it is 0 by 0 form. What was there to get confused about? It is obviously 0 by 0 form. So what is the expansion of e raised to x? Anyone remembers e raised to x? So it is 1 plus x by 1 factorial plus x
x
square by 2
square,
factorial plus
x cube by
and
3
so on.
factorial.
So you can just substitute this value over here. So it is 1 plus x by 1 factorial plus x square by 2 factorial and higher order terms. This is e raised to x minus 1 whole divided by x. So this 1 and 1 will get cancelled. So you will be left with 1 by 1 factorial plus x by 2 factorial and higher order terms. And now you are making your limit extending to 0. So what will this thing go to? Where will this thing go?
1 by 1 factorial.
1 by 1.
What is 1 factorial?
1.
What is
1,
1
sir.
factorial?
One.
Yes. So 1 by 1. So my answer will be 1. Correct. Answer is 1.
Yes.
Correct. 1. Okay. So now can we just think of one similar question? Limit x tending to 0, a raised to x, where a is any constant. What will this value be equal to? Can we think of something? Can you just establish a relation by variable change between this and this? Can we change our variable so that we reach here?
Yes.
Okay. So if you are not able to do it, I can take a variable. See, I have a raised to x and I would want to convert it to e raised to x. What can I do? Just think. So you can use your basic property. So you can treat it as log base a e. If you multiply it by log base a of e, so it will be log base a of e whole to the power of x. So it will be e raised to x. Okay, great. So I will take my variable. I'll take a variable y whose value is x into log base a and e. Fine. So if my x is tending to 0, where is my y tending to? If my x is tending to 0, where is my y?
0.
Anyone? Obviously, this is a constant value. This is a constant value, so nothing to worry about. So now I have limit y tending to 0. So in place of x, I will be putting this.
Y.
Okay, just a minute. In place of x, I would need that. Okay, so I will be dividing it. It will be log base e and a. This thing. Again, y will be 0. Okay. So I have, tell me, it will be a raised to what? What should I be putting? And what should I be dividing? If my y is equal to x into log base e of a, how do I write my x? How can I write my x? I can write it as y divided by log base e and a.
Raised to E.
Everyone?
Yes, sir.
Yes. So what is the, if all of you remember, I have 1 by log base b and c. Okay. If you remember the property, 1 by, so this can be written as log base c and b. My base and this input can interchange if I'm taking the reciprocal. Fine. Does anyone remember?
Yes, sir.
Okay. Okay, great. So this thing can be written as y into log base a into e. So it is a raised to, tell me now, how do I write this thing? A raised to x. So x is equal to this thing. So now I can write it as y into log base a e. Okay. Divided by x. X can be written as log base a e into y. Okay. So just looking at the denominator for little bit time. So I have a raised to y into log base a e. So I can write this as a log base a e whole to the power of y. What is this thing? What is this thing? A raised to log base a e.
A, sir.
Log e to the base of a.
E, sir. E.
A. Is it a? E,
E,
correct.
sir.
It is e to the power of y. Yes, correct. It is e to the power of y. So this thing becomes limit y tends to 0, e raised to y minus 1 by y. And now I have 1 by this thing, 1 by log e to the base of a. So if it is 1 by, so I can just invert it. So it is log base e a, just taking the reciprocal. Now what is this value? E raised to y minus 1 by y. E
1,
raised
sir.
to y minus 1 divided by y. Correct. It is 1.
Answer.
So my final answer is log base e,
C.
right?
A.
This can also be written as ln of a. Okay. So see, you should be just familiar with all of these terms. Okay. So just one last series before we complete today's session. Right. Is this 0 by 0?
Yes,
Is
sir.
this 0 by 0?
Yes.
Sure. Sure. Yes,
Yes, sir.
obviously, like ln of 1 is 0. What is the expansion of ln of 1 plus x? Anyone? ln of 1 plus x.
1 plus x square by 1 factorial.
Can you tell again? 1 plus? Okay, x minus x square by 2 plus x cube by 3 minus x raised to 4 by 4 and so on. Fine.
Yes.
So you can take ln of 1 plus x divided by x. So obviously 1 minus
1 minus
x by 2
x.
plus x square by 3 minus x cube by 4 and so on. So what will happen if you impose the limit x tending to 0? Limit x is tending to 0.
1, sir.
Correct. Because all the higher order terms will go to 0. So this will turn out to be 1.
1.
Correct. 1, right? 1. Okay. So that's it for today. So I hope all of you have this book of JEE Main. I don't know. Singage. Ghanshyam Tiwari.
Yes,
Right?
sir.
Okay. Okay. So I would just want you all to have a look at page number 19.8. Okay, just a minute. You can have a look at page number 19.8 and 19.9. Fine. 19.8 and 19.9.
Yes,
Okay.
sir.
So that's it for today. And the 3 questions that we have discussed. Okay. Okay, so just complete this question. Okay, it is really important because from this you will understand how to multiply two infinite series or two series to check if it is growing greater than or lesser than 1. Okay, so yeah, that's it for today. Thank you. Ma'am, please. Chandrika, ma'am.
Yes, sir. Yes, sir. Is it done, sir?
Yes, yes, sir, done.
All right, sir. Chandrika ma'am is actually busy with some other session, so I'm here.
Okay, okay, sir. Oh,
All right,
okay.
sir. Thank you so much, sir.
Yes, sir. Thank you. Thank you.
Thank you, sir. Students, join the next session, next link.